For most of modern history, recording media was a struggle of physics. Locking a fleeting human reality into a permanent format meant physically forcing a signal into a tape or cutting a jagged groove into a record. When Paul McCartney woke up with the melody for Yesterday in 1965, he didn't immediately record it. He spent an entire month verifying the melody with other musicians, convinced his brain had plagiarized someone else's work instead of producing an original spark. Once the melody was his, capturing it was a logistical fight. Studio engineers had to position a single microphone to balance McCartney's acoustic guitar, which was bleeding heavily into his vocal mic, all while a string quartet played live right beside him. Capturing a moment in the analog era meant relying on heavy hardware and manual labor to trap an imperfect physical performance. Digital tools replaced the tape and the stylus, but the underlying friction remains. An editor trying to construct a high-tension IPL cricket highlight reel today still faces a massive manual workload. To build a single one-minute sequence, an editor downloads over 80 disjointed clips, scrubbing manually through gigabytes of footage to hunt down the perfect slow-motion swing or a tight close-up on the batsman's face. They then have to manually align these fragmented pieces on a timeline, battling mismatched camera frame rates and searching for the exact visual cue that matches the roar of the crowd. Over a long timeline, this leads to sync drift, an error where the audio and video slowly peel apart, breaking the immersion of the match. Even with digital timelines, creation is a messy, tedious process of fighting against the friction of reality to make the pieces fit. To solve that friction, developers built software designed to automate the alignment of human signals. AI audio tools bypass human hearing, reading uncompressed files as data landscapes. A scanner maps the peaks and valleys of a recording. By identifying those data peaks, the algorithm takes disjointed camera angles and snaps them into subframe alignment, eliminating the physical clapperboard. The algorithm has successfully mapped the structure of a raw recording, automating the precise alignment that once required hours of manual labor. This capability quickly evolved. Algorithms stopped just matching sound waves and began to interpret human language. In this visualization of an automated lyric generator, the system processes a raw vocal track to calculate the precise millisecond a human mouth forms a specific syllable. It dynamically generates text, scaling up and stretching the words to match the exact breath timing and phrasing. This predictive mapping allows the system to follow the natural rhythm and cadence of human speech. Mapping the timing of a human performance creates a structural blueprint. Once a machine can predict exactly when a sound occurs, it can use that same logic to calculate the visual data that should accompany it. Today, a user can bypass physical cameras and microphones entirely by typing a prompt. Last ball, match tied, batsman hits a six. Inside its black box, the AI takes that text and autonomously calculates the physics, the stadium lighting, and the ideal camera angles required to fulfill those words. It calculates a sprawling sunset stadium and a massive cheering crowd, rendering the visual tension of a tied match purely from its own internal data. The result is a photorealistic sports highlight that mimics human emotion and physical impact perfectly, without a single frame ever being recorded in physical space. The predictive feedback loop is closed. The machine now generates the entire event from its own internal calculations. The tools we built to clean up background noise or sync our camera feeds have evolved into autonomous reality engines. This evolution is erasing the physical lens, the boundary that separated what is physically recorded by a human from what is mathematically calculated by a machine. When digital generation becomes truly flawless, how do we as viewers trust our own eyes to identify the truth? The next time you watch a perfectly synced, high-tension video online, you have to accept that it might not be a captured moment of human reality. It might just be the output of a prediction window.